So what we're looking at here is a timeline of the cell cycle, but it's simplified a little bit because we're only looking at interphase and mitosis. So basically the time when the cell is and isn't in mitosis. Interphase contains G1 S phase and G2 phase, and then mitosis is separate. And throughout this timeline, we're seeing multiple passes through the cell cycle. And below that here, we're looking at two things. We're looking at the concentration of mitosis cyclin, or M cyclin. And so this reddish pink line shows how much M cyclin is in the cell, and we see that sometimes there's no M cyclin at all, and other times there's quite a bit. And the other thing that we're seeing in these green areas is the activity of the M-CDK complex, or the mitosis cyclin-dependent kinase complex. And so that is when that complex is going to be adding phosphate groups to other proteins to either increase or decrease their activity, or turn their activity on or off. So when we go through and look at this, we notice that during mitosis, we have the concentration of M cyclin increasing. So we have more and more M cyclin molecules in the cell, which means that they can bind to the M-CDK, and that can become active so long as it doesn't have a phosphate group attached to it. You could look at my other video for details on that. And so that increases the activity of the M-CDK complex, as we see in this green area, this green hill going up. And then we see that the activity decreases really suddenly at the end of mitosis, and that is because these cyclins are actively being degraded. So, sorry, that's the CDK, but the cyclins, as we see by this line, they are actively being degraded, so there are no cyclin molecules in the cell at the end of mitosis. And so that is a good thing because it's telling the cell to move out of mitosis. So there still are CDK molecules because the cyclin-dependent kinases are always present in the cell, but the cyclins are not there. So since they are cyclin-dependent, when the cyclins are gone, then it means that those CDKs are not going to be active for the M phase or mitosis phase. Then as we go through interphase and as we go through S phase and G2 and approach mitosis, the number of M cyclins or mitosis cyclins goes up again, so then they could start binding to the M-CDK again, and the M-CDK becomes active and again starts influencing the activity of other proteins as the cell is in mitosis. And then we see again the concentration of cyclins drops off and the activity of CDK drops off at the same time, because you can't have M-CDK activity if the cyclins are not present.